Welcome again to the continuation on the vectors that I started with you in the previous videos. In the previous videos, we started looking at the vector law that governs a parallelogram, and we've done a detailed explanation on it, and also we've solved an example on it as well in the previous videos, and I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to solve another example on it so that you get a better understanding of it. So this is example 2, as you can see from the board. So it means we've already done example 1 in the previous video, and I will encourage you to do well to watch the previous video, because the previous video lays the foundation, the basic knowledge that you need about the vector law that governs a parallelogram. I've done all those explanations into detail in the previous video. Okay, so do well to watch them so that you can easily handle this session as well, because you are going to apply the knowledge in those videos here. Okay, and please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and take a look at the question that I have on the board. Let's read it together. Okay, so example 2, it says that the point A minus 2, 1, B 2, 1, C 1, 4, and D P Q are the vertices of a parallelogram A, B, C, D. Find the vector AB and the vector DC, and we are being also asked to deduce the values of P and Q. Okay, so first of all, the question is in 2 parts. Okay, the first part of the question says we should find the vector AB and the vector DC, and the second part is saying that we should deduce the values of P and Q. Okay, let me read it one more time before we proceed to solve it together. Okay, so let me read it again. It says that the point A minus 2, 1, B 2, 1, C 1, 4, and D P Q are the vertices of a parallelogram A, B, C, D. Find the vector AB and vector DC. And also, the next part is saying that we should deduce the values of P and Q. Okay, and we've already solved an example on this in the previous video, so we are going to apply that same knowledge here. Okay, so first of all, I explained it to you that you need to first draw the parallelogram. Okay, so we need to draw the parallelogram first and label the vertices of the parallelogram using the points that we have on the board. Okay, so let me write down my solution and let me draw the parallelogram, and let's start. Okay, so I'm going to draw my parallelogram. So this is my parallelogram. Okay, and the next thing to do is to label the vertices of the parallelogram. Okay, so I'm going to label the vertices of the parallelogram, which I've taught you in the previous video that there is a particular pattern that you need to follow. You don't label the vertices anyhow you want. You follow a particular pattern. Either you move in the clockwise direction or the anti-clockwise direction, because if you mix them together, it will affect your solution and your answer will be wrong. Okay, this I've explained a lot in the previous video. Okay, so let's label the vertices of the parallelogram that I have on the board using the point given. Okay, so it says that the point A minus 2, 1, B 2, 1, C 1, 4, and D PQ. So these are the points that you are going to use to label the vertices of the parallelogram. Okay, so when I start from here as A, I will choose to move in the clockwise direction. So here will be my B, here will be C, and here will be D. Okay, I hope you understand. Okay, so someone can choose to start from this point. You just need to follow the pattern. Either you move in the clockwise direction or the anti-clockwise direction when you are labeling the vertices. Okay, so now let me go on the board and also bring the point given. Okay, so the A, we're giving the point A to be negative 2, 1. So I'll bring my negative 2, 1 here. Then the B is given to be 2, 1. So I'll bring my 2, 1 here. And the C is given to be 1, 4. So I'll bring my 1, 4 here. And the D is given to be PQ. Okay, so bring your PQ. I hope the explanation is clear enough up to this point. Okay, now the first part of the question is asking us to find vector AB and vector DC. Okay, so let's proceed and do that together. Okay, so for me to find my vector AB, I've explained this a lot in the previous videos that it is always the position vector of the last letter minus the position vector of the first letter. Okay, so the last letter we have here is B, so it is the position vector of the B minus the first letter we have here is A, so the position vector of the A. Okay, that's how we go about it, and we've done a lot of examples on this in the previous videos. Okay, so my AB will be equal to OB, okay, which is the position vector of the last letter, minus OA, which is the position vector of the first letter. Okay, so minus my OA. I hope you understand up to this point. Okay, so now let's just go and input our values now. Okay, so I'm going to repeat my AB here because that's what I'm looking for. Bring your equal sign. Your OB is given to be 2, 1. Okay, so in place of the OB, I'll put the 2, 1 there. Okay, so I have my 2, 1 minus my OA is given to be minus 2, 1. So in place of the OA, I'll put the minus 2, 1 there. Okay, so minus 2, 1. I hope you understand up to this point. Okay, so this we simplify further. We are just going to apply the knowledge that we've gotten on the addition and subtraction of vectors here. We've done this in the previous videos. Okay, so we are going to do exactly that. So my AB will be equal to 2 minus minus 2. It will give me 4 because when two negative meet like this, it becomes positive. So 2 minus minus 2, it becomes 2 plus 2, which will be 4. Okay, so I'm going to have 4. Then 1 minus 1, it will give me 0. So my vector AB equals to 4, 0. I hope you understand up to this point. Okay, so now we need to also find the vector DC. Okay, so I need more space to continue. Okay, so I'm going to clean a portion of the board. Okay, so this is the vector AB. We've gotten the answer, which is 4, 0. We are done. Okay, so I'm going to clean this side so that we can have enough space to find the vector DC as well. Okay, so let me write the vector AB, the answer somewhere down. Okay, so that we can make reference to it. Okay, so let me write it here. So we have that the vector AB equals to 4, 0. Okay, so that I can clean this portion for us to solve for the vector DC. Okay, I hope you understand up to this point. So let me clean this for us to calculate for the vector DC. Okay, so again, so the vector DC will be equal to, don't forget, the position vector of the last letter minus the position vector of the first letter. Okay, so it's going to be OC minus OD. I hope you understand. The last letter is C. Its position vector will be OC minus the first letter, its position vector is OD. Okay, so the first letter is D, its position vector OD. Then you just need to input your values now. Okay, so repeat your vector DC which you have here. The OC is given to be 1, 4. Okay, so in place of the vector OC, I'll put the point there. 1, 4. You write it in vector form. 1, 4 minus the OD. We have it to be PQ. Okay, so in place of the OD, I'll put my PQ there. I hope you understand up to this point. Okay, so now let's simplify further. So my vector DC will be equal to 1 minus P. It will still give you 1 minus P. I hope you understand. Then 4 minus Q, it will give you 4 minus Q. Okay, so this is your answer for finding the vector DC. I hope the explanation is clear enough up to this point. Okay, so now the next part of the question, it says we should deduce the values of P and Q, and this is where we are going to apply the vector law that governs a parallelogram that we learned in the previous video. We are going to apply it here. Okay, so it says that we should deduce the values of P and Q. Okay, so now from the parallelogram that we've drawn here, I hope you can all agree with me that we can say that the vector AD, okay, the vector AD is equal to the vector BC. Okay, or someone can say DA. Okay, so when you choose to move from D to A, your arrow will point towards A. And if you choose to move from D to A, then it means here also you move from C to B. I have chosen to move from A to D, so my arrow points towards D. Okay, then of course it means that the opposite side also will move in the same direction. So I have to move from B to C. Okay, this I've explained a lot in the previous video. I explained to you that the opposite sides of the parallelogram, they have to move in the same direction. Okay, so now having AD here, here also I have to move from B to C. Okay, and also we can also say that my AB should be equal to DC. I hope you understand. Okay, I'm moving from point A to point B. So it means when I come to the opposite side also, I'll move from D to C. Okay, the arrows need to move in the same direction. The opposite sides of the parallelogram, they are equal. Okay, and also the arrows need to move in the same direction. The opposite side, it needs to have the arrows moving in the same direction, which is very important. I've explained this a lot in the previous video, so we are applying that knowledge here. Okay, so now let's go ahead and find the values of P and Q. The next part says we should deduce the values of P and Q. Okay, now from what we've already calculated, you can agree with me that we've already found the vector AB, which is 4, 0. I hope you can remember. That's the first part of the question. We have to find the vector AB and DC. The AB we got 4, 0. And also we found the vector DC, which we are having 1 minus P, 4 minus Q. So we are going to make use of them, okay, to find the values of P and Q. Why? Because when we come to the diagram on the board, we can say that the vector AB is equal to vector DC. I hope you can agree with me on that. Okay, so I'll have that my vector AB is equal to vector DC. This is the vector law that governs a parallelogram. Or someone can choose to do vector AD. Vector AD equals to vector BC. Okay, and you will still get the same answer. So if you want to use this or this, you get the same answer. But the reason why I want to use the first one is because we've already solved for the value of vector AB, so we can just input it in. And also we've already solved for the value of vector BC, so we input it in and we solve for the values of P and Q. Whereas when you choose to use this one, which is vector AD equals to vector BC, you get the same answer, but the thing is that you have to now come and find your vector AD, okay, because we've not solved for vector AD in this question. So you have to solve for vector AD and also solve for vector BC. Then you equate them and solve for the values of P and Q, okay, that's the only difference. So I'll stick to the first one so that we can make our work very easy, because we've already solved for the vector AB and the vector DC on the board. Okay, so let me clean this side so that we can continue. Okay, so I'm going to input my values. The vector AB, I have 4 zeros, so in place of the vector AB, I'll put my 4 0 there, equal to, then my vector DC, I have 1 minus P, 4 minus Q. So in place of the vector DC, I'll put my 1 minus P, 4 minus Q there. I hope you understand up to this point. Now this becomes equality of vectors, and I've taught you equality of vectors, so we are going to apply that knowledge to solve for the values of P and Q. Okay, so let me write this one more so that you can see it, okay, clearly. Okay, I can see this side is not appearing clearly there, so let me clean it and write it off. Okay, so I have 1 minus P and 4 minus Q, okay, so that you can see it clearly. I hope it's clear enough now. Very good. Okay, so now we are going to clean a portion of the board so that we can continue. I need more space. Okay, so I'm going to clean this side so that we can continue from there. But I hope you understand the explanation up to this point. Okay, so let me clean here for us to continue and solve for the values of P and Q. Okay, so this is equality of vectors now. So we are going to equate corresponding components. When two vectors are equal, it means their corresponding components are the same, meaning that we can equate the corresponding components. So when I take the 4 here, I will equate it to 1 minus P and solve for P. And when I take the 0 here, I will equate it to the 4 minus Q and solve for the Q as well. This we've treated in details in previous videos, so we are just applying that knowledge here. Okay, so let's go ahead. So when I take my 4, it will be equal to 1 minus P. Okay, and to get my P, I'll let this P cross to this side so that it can become positive. It is negative here, so that the 4 will go here so that it will be negative there. So negative P crosses the equal sign, become positive P here, equals to my 1 is there, the 4 will go there, becomes minus 4. So my P equals to 1 minus 4, it gives minus 3. So my P equals to minus 3. And I hope you understand up to this point. Now, let's go ahead and solve for the Q as well. Okay, so I'll take my 0 here and equate it to the 4 minus Q. So 0 equals to 4 minus Q. And I'll let the Q cross to this side. Okay, so I have my Q will be equal to 4, this 0 goes there, minus 0. Okay, so my Q will be equal to 4 minus 0, it will give you 4. Okay, so this is the values of P and Q. P is minus 3 and Q is 4. Okay, so this is how to go about the question. And I hope the explanation is clear enough and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we solve another example on this. Bye bye.